Hello, welcome to lesson 2 on the topic reaction rates and reversible reactions. In this lesson, we want to consider the effect of surface area on the rate of a chemical reaction. Let us consider these two shapes. The one to the left depicting a small surface area and the one to the right depicting a large surface area of reactant particles. We want to consider that these two surfaces are reacting with the same number of reactant particles of another substance. We see that when we have the small surface area, the number of reactant particles from the other substance colliding successfully with the small surface area is small, meaning that out of 4 reactant particles, only 2 get to react with the small surface area. On the other hand, with the large surface area, all 4 reactant particles from the other substance collide with the large surface area. With this observation, we can then say that we have few successful collisions with a small surface area, and that would mean that we have a lower rate of reaction. We have many successful collisions with a large surface area, and that will mean that we have a higher rate of reaction. But then, in reality, how can we really look at this variation in surface area of reactant particles? Let us consider a cube whose dimension is 2 centimeters. That means all the sides are equal and each has a length of 2 centimeters. If we are to work out its surface area, we find that we have to multiply the area of one face, which will be 2 by 2, and multiply the result with the total number of faces of a cube. A cube has 6 faces. In this case, we have 1, 2, and 3 that we can see. And then behind the diagram, we have another 1, 2, and the bottom, which makes another 3. So that it all totals up to 6. So therefore, in working out the surface area, we can say that we will multiply the area of one face with the number of faces. The area of one face with a dimension of 2 will be 2 multiplied by 2, and then we multiply by the 6 faces. What result do you get from this? Hopefully, you've used your calculator or you've done mental arithmetic and you get 24 square centimeters. Let us look at a similar cube with dimension of 2 centimeters. This time, however, we want to cut the cube into smaller cubes with dimension of 1 centimeter each. So this is what we do. Cut it up, and then let's work out its surface area. When working out the total surface area this time, we realize that because the cube has been exploded or else cut and each cube separated, then we have more surface area exposed for reaction. We'll want to consider that probably each of these faces is being in contact with a fluid when immersed. And therefore, to get the total surface area, this time we'll say that we get the area of one face, multiply that area of one face with the total number of faces for that particular cube. But now, because we have more cubes, then to get the total surface area, whatever surface area we get for one cube, and all the cubes are identical, we multiply by the number of cubes. How many cubes are there in this exploded view of the cube of 2 centimeters cut to smaller cubes with dimension of 1 centimeter each? Work it out and let us see if we will have the same answer. So hopefully you have done your calculation and you have said that the area of one face is 1 by 1. The total number of faces for one cube is 6. And then the total number of cubes is 8. Let's count and see if we indeed have 8 cubes. This will be 1, 2, 3, 4, 5, 6, 7, and then there is another cube behind all of this, which makes 8. So we have cut one cube into 8 cubes. What is the total surface area this time? Did you get 48? Good. But now we then see that when we cut up a cube into smaller cubes, then the surface area is increased. We can therefore make a conclusion that the surface area of a reactant particle can be increased by cutting it into smaller pieces or even by grinding it. And so, with that in mind, then if we choose to look at the reaction of magnesium, for example, we can say that 2 grams magnesium powder exposes a higher surface area for collision with hydrochloric acid particles, while 2 grams magnesium ribbon exposes a lower surface area for collision with hydrochloric acid particles. And so we see that this separation indeed has increased surface area for collision. Tune in to lesson 2B so that we then see how we can measure the rate of such a chemical reaction. Thank you and have a nice day.